let me use a blue pen. Glycogenesis. Wow. So let's take a little recap. In the liver, the processes that happens in the liver, you have glycolysis and glycogenesis. When glucose comes in, insulin stimulates the receptor TKR and allows glucose to become pyruvate, which later becomes acetyl-CoA and goes into Krebs cycle and all that becomes ATP. So it stimulates the glycolytic pathway. It also stimulates the conversion of glucose to glycogen through glycogenesis. In the muscle, it allows the entrance of glucose by stimulating TKR to allow GLUT4 allow the entrance of glucose. So it stimulates glucose uptake from the liver. Do not forget, hyperglycemia is the stimulus. That's why insulin is being produced. So it allows GLUT4 to come in, that is glucose uptake. It stimulates also the amino acid receptor to allow amino acid uptake into the muscle. So when it comes in, it undergoes different modification that produces protein through protein synthesis. It also undergoes protein synthesis. It allows the glycolytic pathway. It allows glycogenesis. So we have 5 different things that happens in the muscle when insulin gets to reduce the blood sugar. This is beautiful. This is really beautiful. I hope you enjoy this video and also make comments and tell me how to improve this video. But please take the key points. I want you to take the key points. They are very vital. All these processes are very vital to understand what insulin really does in the body, and it's beautiful. It's really beautiful. So I'm just gonna clean here. So now we have, let me just bring this back. So my blood, so it's in the bloodstream now, so insulin. So now this is a representation of my adipose tissue. This is an adipose tissue. My adipose tissue. One adipose tissue cell. The cell of the adipose tissue is called the adipocytes, mind you. So now don't get tired. On the body of the adipose tissue, we have the GLUT4 transporters, glucose transporter type 4. So it is dependent of GLUT4 is dependent on insulin, so it needs insulin to activate it. So insulin comes from the bloodstream and attaches itself here, stimulating the TKR, tyrosine kinase receptor. We all know that now. PI3K and protein kinase B. So this now stimulates the GLUT4 to do what? To allow the entrance, to yank off glucose from the bloodstream and bring it into the cell. So glucose is now into the cell. The adipose tissue is now into the tissue. The adipose cell, it's inside. So by the activation of this tyrosine kinase receptor to allow glucose to come in through the GLUT4 transporters. So what's the first thing it does? It allows glucose uptake. It allows glucose uptake. That's the first thing. Now, this is where I want your minds to be, because it's another very, very important key point. It's a very, very good and important key point. So in the glycolytic pathway, we know glycolysis becomes glycose 6-phosphate, becomes glucose 6-phosphate, becomes glucose 1,6-bisphosphate, becomes fructose 6-phosphate, becomes fructose 1,6-bisphosphate, becomes dihydroacetone phosphate and glyceraldehyde 3-phosphate. Good. So we know glucose becomes dihydroacetone phosphate and glyceraldehyde 3-phosphate. So I'm just going to write it like this: glyceraldehyde 3-phosphate. Beautiful. This is what insulin does. After stimulating the TKR to produce PI3K and AKT, which is the protein kinase B, those intermediates stimulate glucose to go through the glycolytic pathway, mind you, glycolysis also. So on the junction of producing the DHAP and glyceraldehyde 3-phosphate, this is what insulin does. Insulin does this. It changes DHAP to form propan 1,2,3-triol, or otherwise called glycerol. I'm just so happy doing this video. Otherwise called glycerol. It converts DHAP to glycerol. That is beautiful. I'm going to write it here. The first thing it does, number 1, glucose uptake. Number 2, conversion of DHAP, dihydroxyacetone phosphate, to propan 1,2,3-triol. Propan 1,2,3-triol, otherwise called glycerol, which is one of the backbone of triacylglyceride, right? Glycerol. This is what it does again. It comes here. This, am I with you? Am I with you? Apart from this, this is what it does. After stimulating the TKR to produce that intermediate that allows this production of glycerol, it also does this. It converts glyceraldehyde 3-phosphate, are we together, into fatty acid chains that allows fatty acid synthesis through a process called lipogenesis. Wow, fatty acid synthesis. 3, it allows fatty acid synthesis. Excuse me. You see these chains here? You see this little chains here? These little chains here. This is glycerol. When glycerol combines with fatty acid, you have your triacylglyceride. Triacylglyceride. So this is glycerol. That is how you make fat cells. That's how you make fat cells, because these fatty chains, what it does, insulin binds to the TKR and allows the entrance of glucose, which also undergoes glycolytic pathway. At this junction of the glycolytic pathway between DHAP and G3P, DHAP is converted to glycerol. It also yanks off, it also helps this particular cell to start producing fatty acid chains through fatty acid synthesis, because this is what happens when glucose, now let me give you a little illustration of how this happens. Glucose becomes pyruvate, beautiful, and also becomes acetyl-CoA. From glucose we have pyruvate through the glycolytic pathway, it becomes acetyl-CoA. These stimulus allow the production of, because acetyl-CoA is converted to fatty acid through fatty acid synthesis. That is the name of the enzyme that allows the conversion of acetyl-CoA to fatty acid. Fatty acid synthesis. It converts acetyl-CoA to fatty acid through a process of lipogenesis that allows the conversion between the bonding of glycerol and the fatty acid chain to form triacylglyceride. So this is beautiful. In the fat cell we have glucose uptake, we have lipogenesis, we have fatty acid synthesis. In the liver we have glycolysis and glycogenesis. In the muscle we have amino acid uptake, protein synthesis, we have glycolysis, we have glycogenesis, and there are a lot of things insulin does in the body. But this little illustration, I hope you understand and have a vivid description of what really insulin does in the body, and how beautiful and how magnificent it is when you have it, and how detrimental it can be when you do not have it. Thank you, and always subscribe to this channel, and do not forget to like and also